Hey all, Robert Miller here. I'd like to share some learning experiences that I've had in math, chemistry, physics, and various engineering subjects that enabled me to not just remember the material, but to actually understand it. And I would like to share some of these concepts that I've learned to separate the difference between just knowing facts and remembering facts and actually being able to understand what they mean and how to use them. So I prepared this presentation for you, and I hope you enjoy it. By taking a given process and breaking it down into a series of steps or unit operations, and then capturing the audio and visual aspects of that particular step, and then placing it in a reference system that everyone can gain access to and see and hear the same thing, you're able to create a process that will capture, retain, and transfer the critical understanding that drives corporate human intellectual capital. Let's look at some applications that would be of interest to you. Presented as a laptop or tablet-based application, an indexed learning system could be a very effective tool for presenting customers with the critical product information they would need in a very specific and detailed manner. Such a system could also be used to capture case studies in human resources, sales, or various production or business processes so that everyone can see exactly the same presentation without variation. One of the advantages of an audiovisual-based learning system is its ability to capture how critical proprietary tasks or functions are done so that the understanding is maximized. And if this system is a audiovisual based database where you can access randomly any information you require, then this makes the system very, very user-friendly. There are two critical success factors that a business must consider if they're going to be a leading edge company. The first critical success factor that a company needs to be aware of is the importance of their physical capital. That's, is their equipment the latest and most competitive so that they can compete with others in the same area? And the integrity of that capital is maintained night and day, whether there are people there or not. And this is an important distinction to be made from intellectual capital that we will see shortly. The second and most important item that we need to consider is the human resource capital of a company. That is, in essence, what your people know how to do. It's the understanding of all of the processes that are in the heads of your people. And when these people leave every night and your factory lies empty, then in fact your company is intellectually bankrupt. And only when they return is your company functioning with its human resource capital once again. What we see here is our physical capital. These are the objects that we can touch and are here night and day, whether they're people that are here or not. And unlike physical capital, it's generally something that is maintained and easily characterized. And then we come to the intellectual capital. That's all the understanding, the cumulative understanding in the heads of all of your employees. That sum total of all the years of experience and who works with who and how they interact together, that is your intellectual capital. And as I said, when these people leave for the evening and there is no one in the plant, the company is theoretically intellectually bankrupt. And it is only when these people return that the company can function again. And it is very difficult to measure the intellectual capital so that you know whether or not you're gaining intellectual capital, maintaining it, or losing it. As you can see from the upper part of the chart, if a process fails in some way because of a physical resource, it can generally be found quite quickly and repaired. However, if there's a failure in the process due to human intellectual resources, it is not easy to track down who didn't know what, who forgot to do this properly, how people did not interact properly. All of these are very difficult to assess whether or not people forgot how to do something, never knew how to do something, didn't understand how to do something. And that's why we have to pay critical attention to the preservation and development of the human resource intellectual capital. In any given situation, there are a number of critical success factors that an employee needs to understand, not just remember, but understand. And we're going to explore those now. I'd like to use the analogy of a person driving an automobile, and there's an accident or some issue that requires them to take an avoidance action. They have to know exactly what to do in this dynamic situation. Do they go to the left? Do they go to the right? Do they brake? Do they go? So they have to be able to make a decision, and they have to understand the consequences of what each of their activities is going to result in. As the accident unfolds in front of the driver, they have to know when to turn to the right, when to turn to the left, when to put the brakes on, when to accelerate. This has to be based on an understanding of how the car is going to behave and what's that going to do to them in terms of avoiding the collision in front of them. And the last issue is the employee needs to understand how to do the various activities that are required in order to get the car to behave in the way to avoid the accident. And this is just not something that you can read in a book. This is something that you have to understand and experience. This type of situation where a person has to react dynamically to a given situation where the parameters could be changing each time they experience it is not something that they can read in a book. It's something that they have to experience and they have to practice it. And that's the way you understand. It's not something that's theoretical, it's something practical. And for all of these situations, the employer has to make sure that the employee understands all of these particular issues. Dr. Edward Deming, the American quality control expert, rightly said that if you take good people, but you put them in a bad system, you're going to get bad results. And if you have the best equipment and the best people, then you want to make sure that you have the best learning system in order to make sure that you have the best business results. And that's why so many Fortune 500 companies are now taking students directly in and teaching them the issues and the subject matter that they deem necessary in order to be productive employees, rather than just relying on an outdated university system to provide them just a piece of paper. 2,500 years ago, many people understood that so many learning processes only taught facts, and they didn't teach people how to understand what these facts meant and how to use them together in order to understand a problem. So, a learning process has to be specifically designed to promote understanding of the content. In a world where all knowledge is readily accessible via the internet and electronic devices, the value of knowing just facts is almost irrelevant these days. What is important is, with the knowledge that you have in your brain, you know the relationship between these various pieces of information, and you have an understanding of how to use them and what they mean, and you can synthesize a solution to a problem based on your understanding of the facts and the issues before you. This is the abstract of a seminal paper we created on the problems associated with manufacturing nonconformances that essentially were very, very, very costly to companies. And it wasn't that the employees wanted to make a mistake, it's they made a mistake because they most often didn't understand what it was they were to do and exactly how to do it. And therefore, we found that in order to solve these problems, it was necessary to create individual learning systems for individual companies that contained their proprietary information. And only in that way could employees successfully carry out the operations they were required to do without error. In the earliest of times, it was possible for one-on-one instruction. A father would teach their son or daughter how to do this or that, capture food, make clothing, and whatever. So one-on-one training was very effective at that point. As society moved along and the number of people that needed to learn increased substantially, it was not really feasible to have one-on-one training, and therefore there was a transfer to text-based information where you would read the information about the subject of interest, and then you would have a dialogue with a professor or someone in a classroom of maybe 100 people. That was not very productive for learning very, very, very much. And so what we ended up needing was a system that could deal with and solve those problems. Let us take a specific case of learning in Canada, the Canadian literacy. We're supposed to be a well-educated country with knowledgeable and technically competent people. So how do we do? Because in order to read all those manuals and those texts, one has to have a literacy level commensurate with the complexity of the text and diagrams, etc., and concepts that you're reading. So, how are we doing? If you ask members of the general public what the literacy level and capabilities are of Canadians, they'll say, well, we're well educated. We don't have a literacy problem. Well, here is the reality of the situation. The reality is that nearly half of all Canadians have a low literacy level with respect to the general language, let alone complex technical language. So the reality is that people who have to read standard operating procedures or texts or manuals are likely to misunderstand what is being written because it may be at a level substantially higher than their literacy understanding is. Let's start at the bottom of the pyramid where we see information. That's all the information in the world. And as you sit down and selectively import that information into your brain, you have knowledge. So these are a series of facts and items that you have accumulated. Now, for example, if you now said that airplanes have wings, so I'm going to make an airplane that has wings, and you just start making wings of different lengths and sizes and shapes, and some are successful and some are not. The reason that you have a problem is you don't understand the principle of how a wing works, and that it has to be of a certain curvature and design in order for it to be most effective. And if you master that understanding, then you can design an optimal wing. And not only that, you can then go to a Formula One car where they're not interested in lift, they're interested in downforce. And you can design a reverse wing to make the car very successful. And this is because you understand the concepts and the principles of how something works. And unless you understand, then you're not going to be able to be of much use to anyone in the industrial world. We need to look at the history of learning to see whether or not, over time, we're getting better or getting worse. If you go back to the dawn of man, learning was one-on-one. As I said, a father or mother would teach their son or daughter physically how to do something, and if they didn't get it right the first time, they showed them again and again and again. And this was one-on-one, and this was pretty effective. And it didn't require any text or anything such as that. It was all visually based learning. As time moved on and it became difficult to have one-on-one learning, we then had to rely on text-based systems in order to satisfy the need of transferring information. But is the current system where a student has a textbook and limited access to the expert, the professor at the front, is that better than the old days of one-on-one? Well, I'm going to tell you that I don't think that it is, and here's why. If we look at the history of learning, we will see that learning and understanding was not necessarily based on textual literacy or being able to read, because we've been making progress for the last thousands and thousands of years without knowing how to read. And the reason is that we've been genetically engineered to learn by synchronizing sight and sound. This is how our brain is wired, and this is how it works. And it is this non-contact, I can see some distance, I can hear some distance away, and the ability to simulate that information that really allows us to form the basis of our ability to learn and understand. And because we're visual learners, this has created a problem because when we're reading text, we have to translate the text into a vision in our mind of what it is that we're seeing and what it is that we have to do. And if we have a misunderstanding of what that text means, then we're not going to be able to execute whatever it is we're wanting to do without error. As you can see, most of us are visual learners, and others who cannot see or hear will have a greater problem in gaining an understanding of something where they are handicapped by either their ears or eyes not working. If we look at this chart, we can see a comparison between the learning style of the normal population and that of technical people such as scientists and engineers. And we can see that on the scientific side, there is a predominance of learning using the visual process. Through research, it's been determined that understanding is only maximized when the learning style is considered. So teach people in a manner that they learn the best. Since the dawn of mankind, we have continued to demonstrate that we learn best by copying the actions of others using our visual memory. It's important to reiterate that mankind has been very successful in learning and understanding how to do things and create new things without an understanding of the written word. An important thing to recognize is that all the other living things on Earth, they're illiterate. Horses, cats, dogs, they can also learn. And they do it through audio-visual learning, not by reading textbooks. Like mankind, all these animals have been genetically engineered to learn by sight and sound. They're visual audio learners. And this is how their brains and our brains are wired to work. And we need to respect that fact when we're trying to teach people to learn and understand something new. Since we are predominantly visual learners, in order to maximize our understanding of a particular subject, we need to be taught in a manner that respects our learning styles. Although we can all see the same thing, because there are so many languages in the world, when we listen to someone saying something, if we don't understand the language, then the auditory part of the learning process is subject to some difficulty. So that's why it's important to make sure if English or French or German is not the person's first language and you're teaching them that their literacy level in the language that you're teaching them is satisfactory. Regardless of our understanding of a particular language, we all can see that there's a building on fire. And if we were just told that there's a building on fire in a different language, we would not understand what is going on. So this is why the visual part of learning is so important. And the second part is making sure that an individual has a high degree of literacy in the language that you're teaching them. In this particular situation, all of the languages that you see on the screen are saying one thing: the house is on fire. And so, although we all understand it visually, we need again to ensure that we have a high degree of literacy in the language that we're learning in. Since our value to an organization is based on our dynamic ability to handle the situations that affect the goals of the company. Our experience then is vitally important, and it's what we learn and understand from our on-the-job experiences that contribute to the value that we can provide to an organization. And so our ability to learn on the job becomes a very important attribute for an individual if they're going to progress within a corporate situation. When you're in school, your entire timetable is devoted to the learning process, and you develop a span of attention that allows you to concentrate and focus on the learning material and give you a much better chance to learn the subject material. When you are out of school, then, and it becomes a part-time job to learn, then you lose that concentration and span of attention, and so learning becomes much more difficult. When you're out of school, it becomes much more difficult to absorb and retain a lot of technical information because your span of attention and ability to concentrate and understand the details becomes much more difficult. As we will see, it's virtually impossible to understand something complicated and technical in just one exposure. One needs to be able to review it again as many times as possible so that understanding is achieved. If you find yourself outside of two classrooms, and in one classroom you see all the students have their hands up and are interacting vigorously with the instructor, and then you look in the second classroom and all the students are sitting there motionless without any expression. What is the content of the student body in each of these? Well, in the case of the ones with their hands up, they're all kids. They don't care. They have no self-conscious worries. They just want to learn. In the other case, where all the students are motionless and without expression, they're called adults. And they don't want other adults to know that they don't understand, so they're not going to raise their hand and say, I don't understand. Because people's literacy skills vary significantly, technical text becomes very difficult for visual learners to read and understand because they have to translate the written word into a visual image within their brain. And there may be a lot of interpretation and filling in the blanks that makes complete and proper understanding virtually impossible. As we will see, many people have trouble correlating the text and diagram and pictures in a technical book in order to understand the concepts that are being put forth. As we will see later, this causes a significant problem. The unconsciously incompetent person is much more prevalent than you might believe. And it's characterized by people who know just a little bit about a topic and then think that they're the world's greatest expert. They could be curing COVID-19 with some sort of Drano or some terrible toxic material, or they could say COVID-19 isn't a problem and all this sort of stuff. And these people do not understand and have enough understanding of the issues, and so they are unconsciously incompetent. And in order to become a learner, you have to be aware that you don't know something so that you can consciously take the effort to learn that you don't know everything. There are two types of processes that we need to investigate to see which one is optimal for visual learners. The first of these processes is called asynchronous learning, and we will learn more about this shortly. The second process is called synchronous learning, and we will shortly learn the differences between asynchronous and synchronous learning and the advantages of synchronous learning. This is an example of asynchronous learning, where you have a complicated diagram and you have separate text explaining what the elements of the diagram mean. In this particular situation, when you're looking at the text and trying to read it and understand, you have to have an image of the pictures or the technical diagrams in your mind, and you're making an attempt to refer to them as you try to understand what the text means. On the other hand, when you're looking at the picture, then you have to try to remember the details of the text which were explaining the picture. The problem with asynchronous learning is that you can only look at one thing at a time, which means if you're looking at the text, you're trying to remember what the content of the picture was. And when you're looking at the picture, you're trying to remember what the text said. So the reality of asynchronous learning is that you can't look at two things simultaneously. You can't do both at the same time. And therefore, you have to go back and forth between the text and the diagram and the text, trying to eke out an understanding of the content of the material. On the other hand, learning that is synchronized hearing and seeing is what comes natural to us and turns out to be the best method for learning and understanding. When the visual component is coupled with audio, we have synchronized learning. Research studies using MRI have shown that the brain patterns of people watching someone do a task and the person doing the task are virtually identical. The research shows that people watching a particular action develop what is called mirror neurons, which means that their brain pattern is virtually identical to the person who is doing a particular task, which means that they begin to understand more clearly what the person is doing. We're all familiar with the concept of bandwidth. In computer technology, we know that the wider the bandwidth, the greater the amount of information that can be transmitted. Well, we'd like to look now at the human visual bandwidth to see how much data can be transmitted using this particular means of data input. When we look at the human visual bandwidth, we see that dynamic vision gives us an amazing bandwidth of 600 terahertz, or 2 to the 49th bits per second. That's because we are able to distinguish a mass amount of colors, luminance or brightness, variations in texture, motion, as well as spatial and temporal effects. And that gives us this amazing effective bandwidth. Simply put, dynamic vision gives us an effective bandwidth that's a billions of times greater than that of just looking at pure text. Text must be converted into a visual image within the brain. For example, if I say car or racing car, a dozen different people would describe the car or the racing car differently because there is not sufficient detail in the term car to give everyone an identical image of the particular car. I would like to now compare the critical attributes of audiovisual documentation with that of a real-time learning experience where you may be part of a group watching a particular activity being done. The first element is dynamic vision. That means the ability to see something as it's working in the real world as if you were there and you had an unobstructed view to the activities that were taking place. The next critical attribute is the ability to deploy digital and optical effects to clarify what one is looking at in order to facilitate one's understanding. That means we can zoom in to a particular item, we could colorize a particular item, and we could label a particular item with arrows and text to further the understanding of the issue. When we have synchronized audio with our visual picture, it substantially clarifies what it is we see so that we have a much better understanding of what we're doing and why we're doing it. As we will see, we rarely have the ability to understand completely something that we have seen or experienced for the first time. And therefore, it's critical that we're able to review the subject matter as many times as is required for us to understand the content. And finally, so that a student doesn't have to wait until a number of students are available to take a class from a particular instructor in a particular location, the ability to see that presentation when they need it, wherever they are, whenever it's convenient for them, is by far the ultimate process for learning and understanding. When your visual reference data system is designed as a hierarchical structural system, it's possible to access any particular video or learning material in 5 or 6 seconds in hundreds of hours of video. This is because of the particular structure of the design. And any element within that can easily be replaced and updated so that it is current and up to date. My particular implementation of a learning module was using our unit operation visual reference system, was to provide an interface that you see above that could run on a laptop or a tablet or over the network. And you were given a number of choices on the topic line, as you see there, about, overview, introduction, and so on, to choose which of the subtopics you wish to choose. On the left, you see a series of tabs: safety, startup, construction mode, and so on. And the one highlighted, standard OTR mode, you see points to a series of other topics. And if you press the tab then, or touch each of the headings there, that would take you to the respective video outlining that particular learning material. Having selected the appropriate video, you see here a frame from a video showing how to clean the end of an optical fiber. And this video would run 2 to 5 minutes long and would be fully narrated. If you look at the chart you see in front of you, on the left-hand side, you'll see method, and below it are the 6 various methods that you can use to transmit information. And in the 3 middle columns, you can see the attributes that contribute to the quality of a particular method. And if you look carefully, you'll see under the system column that only the UVRS procedure is a best practice procedure because it has real-time audio, it has the dynamic motion effects, and it has all of the attributes of zooming and titling and everything that you need. Yes, you've just graduated from college, and you may have multiple degrees and know all sorts of great stuff, and probably could be a great professor teaching people things. But if you're in an industrial company, what is it that you know and can do that will pay for your salary? And I think we need to look at that in some detail. The reality is, for the most part, that a company will pay you to do things that specifically add value and enough value to cover your salary. And that doesn't mean repeating the knowledge that you gained at a university or college. It means the information and skills and understanding that you're going to gain in the specific company that you're working at. And this is so vitally important now that major Fortune 500 companies are recruiting kids before they go to college because they don't want them wasting their time in programs that are outdated and do not provide individual companies what it is they need to survive. They would rather teach these young, smart kids what they need to know on the job. When you join a new company and have to learn about the processes and systems within that company, if you're given a standard operating procedure that's pages and pages and pages long, and all you have is text, and it's in English, and it's at an elevated level, and your first language is not English, then there are going to be issues with your ability to assimilate and understand what it is that you're supposed to do and how are you supposed to do it. So the reality is that if you're one of many and you're only given procedures that are documented in a written text form, and as one of many, you only have limited access to the expert, it's going to be very difficult for you to totally understand how and why each particular step of an operation is to be done using that procedure alone. I'd like to take the time to explain this chart to you in particular detail. If you look at the y-axis, the vertical axis, you'll see that it's scaled in understanding. And if you look at a bar over on the chart, the higher the bar means for the content of that particular bit of information, one has a higher degree of understanding. Along the bottom, you see it being numbered from 1 through 5. And that's the number of individual points within a subject that you have to grasp in order to have a total understanding. And then when you look at the z-axis, which goes back, you'll see that it's the number of times that we review the particular bit of information. And the first thing that we see looking at the first series of presentations, which are shown in the red bars, is that no one understands what it is they're talking about the first time in complete detail. If it's a technical subject, it takes a number of times to learn that. And as you see in the yellow charts, they're all slightly higher than the red ones, which means the second time that you are presented with it, you get a better idea of what's going on. And as you move back to the green, then that's even higher. And finally, when you reach the purple, you have a complete understanding. Now, this also implies something else. It means if you don't do something for a period of time, that which was most difficult to remember is most easily forgotten. And so you would have an issue with the process captured in video clip 1 if you were not able to continually review the material. So this shows that in order to maintain a consistent level of understanding, you must have access to the material to be able to review it as many times as you need whenever you need it. It's unfortunate that so many college and university courses rely upon one's ability to recount knowledge, facts that they've learned, and their ability to graduate is based on this ability to remember rather than understand. And that creates a problem because in today's modern world, with access to the electronic internet and the ability to find out any particular fact you need to know, it makes this ability to remember so much almost an irrelevant capability. Since so much of the knowledge and facts that we know are set forth in textbooks, we need to look at some of the disadvantages of text as compared to visual learning. The old saying that a picture is worth thousands of words could not be truer in today's world. Text is a very short form, like shorthand, for describing the visual world. And because of that, it lacks the detail and the depth necessary to provide one with a complete understanding of the subject. As we have seen, text is a linear process. It's one-dimensional, visually encoding information using pattern recognition of specific language characters. And there's 266 languages on record. And there's hundreds of different fonts. And then there's the variations in one's ability to read handwriting. And when you put all of that together, it makes the written word very difficult sometimes to allow you to master the understanding of a given topic. Another problem with text is that reading SOPs, one reads words and not letters within the word. And there can be many words that are similar but have different meanings. And so it's very easy to misinterpret what the meaning of particular words in a sentence might be, as you can see by looking at the given text above. You can see that the spelling is completely wrong, but yet you have a sense of what is being said. For a learning system to be effective, it must contain standardized content. That means the content is identical each and every time to each and every one. It also needs to be certified by experts to ensure that there are no errors or omissions in the explanation. In addition, each video segment must accurately show how each and every unit operation is to be carried out in detail with no omissions or errors. Each video clip must demonstrate the exact meaning and interpretation of the written instruction. So if the instruction said, carefully withdraw the nuclear detonator from its cylindrical holding, slowly, while rotating it in an upright position, that could leave some room for interpretation that just might write in a nuclear explosion. Finally, the learning module should be able to provide the rationale and explanation as to why a particular activity is being done in a particular way. The audio portion needs to supplement what is being seen by having one be explained what is going on and why it was being done in that particular fashion. As you can see, an audiovisual based learning system where it's a show and tell situation where we show you what to do and tell you why, that has the greatest possibility of eliminating employee errors that result from misinterpretation of text. That system also allows you to capture the intellectual capital held by your most experienced employees so that this is not lost. And so you know that the intellectual capital of your organization does nothing but increase. Also, this allows you to have an anytime visual instruction, and that could supplement or eliminate costly instructor-led sessions that are scheduled at a particular time in real-time sessions that you need to coordinate your schedule with the instructor's schedule. And that really means that the delivery is not location or time dependent, and therefore meets the total needs of the person or student who wants to learn and understand the material in question. And why are we worried about the retention of intellectual capital? Well, the reality is that the baby boomers who created and built the infrastructure that we enjoy today, well, 40% of that skilled workforce was scheduled for retirement by 2015, and it continues today. And we have a labor shortage of these type of people. But it's not merely replacing headcount. As we saw earlier, it's replacing the intellectual capacity of the organization and not losing that when people retire. Because of the retirement of these baby boomers, it's been estimated that large companies could lose more than $100 million in productivity because people do not know how to do what their former predecessors knew and do what they do much slower. And the company must now recruit new employees and engage in a costly training program to try to bring them up to the level that former employees had. And this is costing a lot of money and is difficult to do using existing training procedures. When Fortune 500 companies were surveyed, 81% of them said that they would be adversely affected by baby boomer retirements. But they weren't sure exactly if they had a process to capture that intellectual experience. For the key processes that generate income for the company, there should be a basic library module on each of the specific processes that are of critical importance. And although that might sound a little expensive, the reality is that the price of nonconformance or errors or loss in market share far outweigh the cost of capturing, retaining your intellectual capital. And optionally, if you have a complex business such as the infrastructure associated with nuclear production of electricity or some other very complex processes, even the automation of particular factory with robotic systems, you might also want to invest in a number of troubleshooting scenarios to facilitate people's understanding of what it is they have to do in particular situations to handle potential non-conformance situations if left unchecked. I would like to take this opportunity to show you some examples of visual learning that I produced so that you can get an idea what is available
Tank TK
and
number
possible.
13 is always empty when a shipment of new oil is expected. All new oil will be unloaded into tank TK number 13, which is the designated holding tank while testing is carried out. Optionally, the new oil may be held in the delivery tanker, pending the laboratory analysis before transferring it to tank 13. In the case that the oil is rejected, the latter situation facilitates the return to the supplier. If the new oil meets the specifications, then it will be pumped to new oil tank TK number 14. If new oil does not fully meet the specifications, then it may be processed once only and placed into the new oil tank TK number 14. The truck and the rail car unloading operation is metered, and the volume unloaded will be printed out in a report to the operator. Pump number 5 is a positive displacement rotary gear pump located on the west side of holding tank number 13 along the retaining wall that surrounds the holding tanks at the CMS facility. Truck access to pump number 5 is via a road that runs parallel to the retaining wall. Rail car tracks are installed along the road, providing rail cars close proximity to the pump area. Spanning the retaining wall at the pump number 5 location is a staircase that provides a means to enter the holding tank area from the road below the wall. Pump number 5 is used to unload oil from a truck or rail car into tank number 13, where it is held until the quality of the oil can be determined by chemical analysis. Oil to be processed through pump number 5 flows first into spill preventer SP5 after leaving the tanker. The spill preventer acts as a reservoir for oil entering the pump and prevents the pump from running dry or without oil flowing into it, which will damage the pump motor. The hose used to connect the tanker to the spill preventer must be a tank truck hose with a maximum working pressure of 150 psi. Check that valve V511 is installed after the spill preventer and only allows oil to flow in the direction of the pump. The purpose of this one-way valve is to prevent oil from flowing back into the spill preventer tank. Following valve V511, oil flows into basket strainer ST5. The purpose of the strainer is to remove damage-causing particulate matter from the oil, protecting system components such as flow meters, pumps, and mechanical seals in the oil loop. Immediately following strainer ST5, oil flows through manual butterfly valve V423 that must be in the open position before oil will flow into the pump. Pressure in the line at the point where oil enters the pump is displayed on the face of a vacuum gauge mounted on the inlet valve after valve V423. Pressure in the line at a point where oil exits the pump is displayed on the face of a pressure gauge mounted on the outlet line after pump number 5. By monitoring the pressure in the line before and after the pump, the operator can determine the efficiency of the pump. Immediately following pump number 5, oil flows through manual butterfly valve V424 that must be in the open position before oil will flow into the flow meter M5. Flow meter M5 is a rotary motion positive displacement volumetric measuring device that is designed to withstand changes in temperature, pressure, and viscosity. It is rated to a pressure of 150 psi or 10.5 bar and will meter accurately from minus 40 degrees Celsius to 71 Celsius. The display on the front of the unit records the volume of oil passing through it in liters. Note that the meter should never be reset while it is counting. The start and stop switch panel for pump number 5 is mounted just below the yellow body of the flow.
I hope you've been able to glean from this presentation that understanding is much more than just having knowledge and facts. And it is only understanding that will give you the ability to think about problems and issues to solve. As Albert Einstein said, if you can't explain something to an elderly person who has no knowledge of the subject, then you really don't understand it yourself. So I hope this presentation has helped to illuminate the importance and difference between understanding and just having knowledge. Thank you for listening to this presentation, and I hope it was of use to you.